Today we're gonna solve a problem in fluid mechanics under Chapter 1, Properties of Fluids, from the book of Gillesania, Fluid Mechanics and Hydraulics, Revised Edition. So, problem 1-36. A shaft, 70 mm in diameter, is being pushed at a speed of 400 mm per second through a bearing sleeve of 70.2 mm in diameter and 250 mm long. The clearance assumed uniform is filled with oil at 20 degrees Celsius with V, or the kinematic viscosity of the oil, 0.005 square meter per second, and specific gravity of 0.9. Find the force exerted by the oil in the shaft. So first, we're going to determine our given. So we have diameter of the shaft. D is equals to 70 millimeter, and converting it into meter by dividing it by 1000. So we have 0.07. Length of shaft, L, is equals to 250 millimeter, and dividing it also by 1000 to convert into meter, we have 0.25. Change in velocity, du. So our change of velocity in du is 0.4 meter per second. So we also divide it by 1000. Kinematic viscosity of oil is equals to 0.005 square meter per second, and the specific gravity of oil is 0.9. Moving on to our solution. So F, or force, is equals to shear stress, tau at the shaft times surface area of shaft, which is A. So we're going to determine the density of oil. So 0.9, the specific gravity of the oil, times the density of water, which is a constant, 1000. So we have 900 kilogram per cubic meter. So next, we are going to solve for the dynamic viscosity. So the dynamic viscosity is equals to 0.005, our kinematic viscosity of the oil, times 900, the density of oil, giving us the value of 4.5 Newton second per second meter, or square meter. So clearance, dr, is equals to dy. So to get the value of clearance, we have to subtract and the value of the diameter of the bearing sleeve, which is 70.2 millimeter. Then subtract it by 70 millimeter, the diameter of the shaft, and divide it by 2 millimeter, giving us the value of 0.1 millimeter. Then converting it into meter by dividing it by 1000, giving us the value of 0.0001 meter. Then moving on to our solution, or our equation. So force is equals to the dynamic viscosity, du over dy, times pi dl. So force is equals to 4.5, our dynamic viscosity, times 0.4, our du 0.4, and divided by 0.0001, our clearance, or dr, or dy, times pi times the diameter of the shaft, 0.07, times the length of shaft, 0.25 meter. So our force, or the force exerted by the oil in the shaft, is 987 Newton. So that would be all, and thank you for watching.